Interest in next-generation solar cells has recently surged after Elon Musk spoke about the potential of space-based solar power. In South Korea, work to commercialize perovskite solar cells is also progressing. But what exactly is perovskite, and why is it drawing so much attention from researchers worldwide? How solar cells work and the limits of silicon. Solar cells are devices that convert sunlight into electricity. They absorb sunlight, causing electrons to move, and this flow of electrons is used to generate electric power. Today, the most common solar cells are made from silicon. Silicon is a semiconductor that controls the flow of electricity well. Given its abundance on Earth and its durability over decades, silicon has become the material at the heart of modern solar cells. Silicon is far from perfect, however. It converts light into electricity most efficiently, only within a specific energy range. Light that is too weak passes straight through unused, while light that is too strong sheds some of its energy as heat. These physical constraints mean there is a ceiling on how much the efficiency of silicon solar cells can be improved. What is perovskite? Originally, perovskite referred to a specific mineral. Today, the name is used for a group of compounds that share the same crystal structure. In other words, it is not a single material, but a family of materials with the same arrangement of atoms. Perovskite absorbs sunlight very efficiently. While silicon requires a relatively thick layer, perovskite can absorb a large amount of light with a much thinner film. In addition, by changing the combination of elements, scientists can control which wavelengths of light the material absorbs best, giving it great flexibility in design. It is these advantages that are drawing attention to tandem solar cells, which pair a perovskite layer with a conventional silicon cell. Under this design, the perovskite layer absorbs high-energy light first, while the silicon layer captures the remaining light, enabling a greater share of the sun's energy to be converted into electricity. The manufacturing process is also different. Silicon solar cells require complex production methods that involve melting and purifying silicon at very high temperatures. Perovskite solar cells, however, can be produced by spreading a liquid solution into a thin film, which is expected to reduce manufacturing costs. Challenges that remain. Despite its advantages, perovskite still has challenges to overcome. The biggest issue is durability. Perovskite is sensitive to moisture and high temperatures, so its performance may decline over time. There are also environmental concerns. Some of the perovskite materials currently being studied contain lead, which can have harmful effects on the environment if the solar panels are not disposed of properly. Even so, perovskite solar cells are important because they are expected to complement rather than replace the limitations of silicon solar cells. Researchers are watching closely to see whether this new material will lead the next generation of solar power technology.